So hello, I'm Abhinav Singh and this is our second lecture of circles, and today we will be covering the following topics. And the first topic that we will be covering is the position of a point with respect to the circle. Next, the power of point, and then the tangent line of a circle, and then we will see the various equations, various types of the equations of tangent that we can write for a circle. Okay, let us. So beginning with, we will just do a question that was in our DPP1, and this is a very important concept, and this we covered slightly in the straight lines chapter 2. So basically the question is that we are given 3 points, and these 3 points are non-collinear, and we need to find the circle that circumscribes all of them. Okay, that if we all join all these 3 points A, B and C, then we need to find the circumcircle of this triangle. So how we will be doing it? For this we have studied that the perpendicular bisector of the sides intersects, if means the perpendicular bisector of all the sides intersects at some point, means all the three perpendicular bisectors simultaneously intersect at a point, and this point is called the center of the circumcircle. This point is the center of the circumcircle. Okay, now we can also see that if we join this point to the vertices, then this line segment is equal to this line segment, because this is a perpendicular bisector. So by right angle hypotenuse, so by angle side angle congruence, this side is same, this side is same, this side is common, and this both angles are same as they are both right angle. So the hypotenuse of both the triangles are same. In a similar way, this side is also equal to this side. So we can see that when we join this point to all of the to each of A, B and C, then AO equal to CO, let us call this O, equals to BO. So it satisfies the property of circumcircle of the triangle. A circumcircle of the triangle is such that it is equidistant from all the 3 points. So indeed O can be the circumcircle of the triangle. So this is done. Now we need to find this O. So let us take this example. AB. First we will find the perpendicular bisector B1. That is called as BC because it is opposite to C of AB. Then to find it, we know that what is the slope of BC. It is minus 1 by times the slope of AB, and AB is lying on the x-axis. So BC is basically perpendicular to x-axis, that is, it is on the y-axis. And the second thing is that it passes through the midpoint of AB, that it passes through 4, 0. So the equation of BC is x equals to 4. Okay, it is some line like this. Now coming to AC. What is the equation of AC? What is the slope of AC? The slope of AC is 4 divided by 6, 2 by 3. This we can easily see. So the slope of this bisector, which we will call BB, will be minus 3 by 2. Okay, this is minus 3 by 2. And it passes through this point. This is the midpoint of AC. So what is the midpoint of AC? It will be 8 plus 2 by 2, 5, 4 by 2, 2. Okay. So if we write the bisector, the equation of BB, what it will be? It will be, first we will write y by x equals to minus 3 by 2. So it will be something like that. 2y plus 3x equals to, now put the values of 2, 5 in it. Then we will be getting 15 plus 4, 19. So our center of the semicircular, center of the circumcircle will be O, and it will be the intersection of x equal to 4 and 2y plus 3x equals to 19, and its intersection will be coming y 4 comma, and y will come 19 minus 12 by 2, that is 7 by 2. So 4 7 by 2 will be this O. And now since we know the center of the circle, we can just find the radius by taking any of the points, and it will be 8 minus 4 to the power 2, that is 16, and 4 minus 7 by 2. 4 minus 7 by 2 is 1 by 2. So this is our radius of the semicircle. This is our center of the semicircle. And hence now we know the equation of the circle, since we know its center and we know its radius. So this is the general procedure how we proceed to find the circumcircle of a given triangle. And there is an important point to note that if all the 3 points are collinear, then there will not be any such semicircle. There will not be any such circumcircle that inscribes all of these. Why? Let us see why is it so. For example, let us say this point is A, this point is B, and this point is C. And we need to find a circle such that all the 3 points lie on this circle. Then by the above method, we can say that the center of the circle will lie on this line, which is the perpendicular bisector of AB. Similarly, we can say that the center of the circle will also lie on this line, which is the perpendicular bisector of BC. Now we can see that these both lines are perpendicular to AC, and hence these both lines are parallel and they are not going to intersect at any point. So we are not going to get the center. Since we are not going to get the perpendicular intersection of the perpendicular bisectors, we are not going to get the center of the circumcircle. So this is the thing, that if ABC are non-collinear, then only there exists a circle that passes through all of them. If ABC are collinear, then definitely there will be a circle that passes through them, because this is a general method. It needs no specifications on ABC except that they are non-collinear. So this is the point, that if ABC are non-collinear, then we can always draw a circle that passes through them. And the general procedure of finding such a circle is by first finding the intersection of the perpendicular bisectors of the line segments joining those points. And then when we have found the center of the circle, we can easily find the radius by finding the distance between the center of the circle and any such point. Now moving on, we will find the position of a point with respect to a circle. We found the position of a point with respect to a circle for a line, and now we will be finding it for a circle. Now we need to find the position of a point with respect to a circle. We did this for a straight line too, and now we will be doing it for a circle. So let us see how we proceed. First of all, this is the circle equation of the circle that is given to us. C, that is x square plus y square plus 2gx plus 2fy plus c equals to 0. Okay, we can write it as something like that: x plus g ka whole square plus y plus f ka whole square minus r square equals to 0. Now we need to see that whether p is outside the circle, or it is inside the circle, or it is on the circle. Now what we know, that for p to be outside the circle, its distance, that is cp, that is the distance of p from the center of the circle, must be greater than r. And if it is greater than r, then what we can write? The distance cp we can write it as, for example, let the point p be x comma y, and c is minus g comma minus f. We know that. So what is cp? It is x plus g to the power 2 plus y plus f to the power 2 and whole under root. So it is something like this. And what is r? It is g square plus f square minus c. And the condition that we need is cp should be greater than r. So we will get this equation, that is under root x plus g ka whole square plus y plus f ka whole square is greater than under root g square plus f square minus c. And if we square it and solve, then we will see that these g square f square terms will get cancelled out, and we will get c on this side. So the equation will be same as you put x comma y in c and make it greater than 0. Okay. And if p lies on the circle, then we know that cp should be equal to r. And if cp is equals to r, then this quantity will be equal to 0. And if p lies inside the circle, then cp will be less than r. And similarly, in just a similar way, the equation will be same, just the sign will be reversed. So this was the thing, that whether a point lies on a circle, inside a circle, or outside a circle, how we can get it. We need to put that point in the equation of the circle, and we need to be precise that the equation of the circle can't be taken anything. Means, yeah, the equation of the circle should be such that the coefficients of x square and y square should be positive. They should not be negative. Okay. And if the coefficients of x square and y square are positive, then if we put x comma y in that equation of the circle, And if it turns out to be positive, then the point lies outside the circle. If it turns out to be negative, then the point lies inside the circle. And if it turns out to be 0, then the point lies on the circle. Now moving on, we will see the concept of power of a point with respect to a circle. What is a power of a point? First of all, let us define it. That is what is its algebraic definition. Okay. So suppose we have a point P, x1, y1, and we have a circle C, x square plus y square plus 2gx plus 2fy plus c equals to c. Now we define the power of P as c x1 y1. That is, we put x1, y1 in the equation of C, and the result we get is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals to c. This was the definition of power of point. That is, for finding the power of point of 2, 5 with respect to x square plus y square equal to 4, what we need to do? We need to put 2, 5 in the equation of x square plus y square equal to 4. Now, this was the algebraic part. Now we must also see what it geometrically implies. So suppose we are given a point P, and if we are given a point P and this is the center minus g comma minus c, then what will be this distance? And the coordinates of the point P, let it be x comma y. Then what will be the distance between P and the center? It will be x plus g ka whole square plus y plus f ka whole square and whole under root, this thing. And this is r, we know that. Now, if we need to find this thing, then by Pythagoras theorem, what we can say? That it will be equal to under root of this whole square minus r square. Or we can say that it will be equal to under root x plus g ka whole square plus y plus f ka whole square minus r square. Now, if we see this equation, then what it becomes? It becomes this only, x square plus y square plus 2gx plus 2fy plus c. Why c? Because we know that r square equals to g square plus f square minus c. And if we do g square plus f square minus r square, it becomes c. So basically, this is power of a point. This is power of p with respect to the circle. So the tangent, the distance of tangent drawn from P to this circle is the under root of power of point. That is, the power of a point is square of length of tangent from P. This is its geometrical significance. Now there is also a very good interpretation of it. That what we did for the position, for what we did for knowing the position of a point with respect to P, with respect to a circle. For example, if P lies outside the circle, then we said that when you put the coordinates of P in the equation of the circle, then it turns out to be positive. Now in a similar way, we can say that if P lies outside the circle, then the tangent drawn from P to the circle should have a real length. And if it has a real length, that then the quantity that is under inside the square root should be positive. And if it is positive, then what quantity is inside the square root? The power of P is inside the square root. So the power of P should be positive. So if power of point is greater than 0, then we can say that the tangent distance is under root some positive quantity. This implies that it is something real. And if it is something real, then a real tangent can be drawn and the point is outside. So you are getting it what I am trying to say. Means geometrically we can say that the condition of P being outside the circle, and from P we can draw a unique tangent, a real tangent. Both these things have same geometrical meaning. And using this, we can say that if P lies outside the circle, then the power of P should be positive. So this is. Now let us do this problem. We are given a point P, which is 2, 5, and we are given a circle x square plus y square equals to 4, and we need to find PA into PB such that AB passes through circle's center. Now, if we are aware of our properties of the circle, which we studied in our earlier classes of 9th and 10th, then we know about the tangent secant theorem. For example, first let us find this PA into PB. Okay. Suppose this is our circle center O, and let us call this distance as D, and this is R, this is R. So PA into PB is basically D minus R into D plus R, which is D square minus R square. Now to be precise, if we just say this PT, what is this length? If this total is D, this total is R, then this 2 is under root D square minus R square. So this is basically a PT whole square. Now let us take any other secant which is not necessarily passes through the center of the circle. For example, let us take this, which is PA prime, PB prime. Then we know that this angle, this one, if this is theta, then this angle is pi minus theta because this triangle is this quadrilateral is cyclic quadrilateral. And if this is pi minus theta, this is again theta. And this angle is same for PA prime A and PB prime B. Now, the angle, let us call this theta and this as theta dash and this also as theta dash because both of these angles are also same in the similar way. So we are applying similarity in triangle PAA prime is similar to triangle PBB prime. Now the angle that is in front of theta prime, what is it? The side that is in front of theta prime, that is PA prime, and same thing here it is PB, and the side which is in front of theta is PA, and the side which is in front of theta is PB prime. So we get basically that PA prime into PB prime equals to PA into PB. That is, and PA into PB is equal to PT square. So PA prime into PB prime is same for any secant, and it is equal to square of the tangent drawn from P to that circle. That is PT square. So for this problem, we need to find PA into PB. We can directly say it as, and what is PT square? It is just the power of point, power of P. This we have just studied. So what we can write? PT square we can directly write as 5 square plus 2 square minus 4. That is equal to 25. So this was the thing, that if you need to find the tangent from P to any external circle, then what you need to do is just put the point P in the standard equation of that circle. By standard equation, I mean that the coefficients of x square and y square should be unity. It should not be something 2 or 3 or negative. So this was it. So this is a very direct method to find the tangent of a circle from an external point. What we need to do, I am again stressing upon it, that we just need to put the coordinates of P in that equation of the circle, and we will get the length of the square of the tangent from the point P to that circle. And it is important to note that if it turns out to be 0, then this definitely implies that the point P is on the circle. And if it turns out to be negative, then this definitely implies that there is no such tangent that you can draw from P to that circle, which implies that the point P lies inside the circle. Now we are talking about tangents from the previous two slides. Now we need to see what is a tangent. Means what is the accurate and most precise definition for a tangent. So let us begin. We know that what a secant is. For example, suppose that this is a curve C and we just draw a line PQ, a line PQ that cuts this curve at some points. Then this PQ is a secant of the circle. This PQ is a secant of the curve. Okay. Now let us say that we fix this point P. Fix. Why we are fixing? Because we need to find the tangent at P. So let us fix the point P and move Q towards P. Now when we will move Q towards P, then we will reach a point when Q is very close to P. And when it is very close to P, then the line, when we extend the line segment PQ, then that line segment PQ becomes the tangent of the curve at P. So basically, if you are given a point x naught comma y naught, and now let us take a point x prime comma y prime such that x prime converges to x naught and y prime also converges to y naught. And both these points lie on curve C. That is, CP equal to CQ equal to 0. Then the line segment, then the equation of the line PQ, LPQ is equation of tangent. This is what tangent is by definition. So I am reading out the standard definition so that it is easy for you. That let P and Q be any 2 points near to one another on a curve. Join PQ. Then PQ is called a secant. The position of the line PQ when the point Q is taken indefinitely close to and ultimately coincident with the point P is called the tangent at P. Now we have studied what is tangent to a general curve. Now we need to find the tangent of a circle. So let us see that how we are going to do it. First of all, we are given a circle. This is the standard circle. X square plus y square equals to a square. We need to, I'm again stressing that in this segment of the chapter, what we will do is we will find things first for the standard equation of the circle, and then we will be extending it to the general case. Okay. So let us see. So let us take the equation of this circle as x square plus y square equals to a square. Now we know this equation of the circle, and let the point P be x prime comma y prime, where we need to find the tangent to this circle. And let us take a point Q, x double prime comma y double prime, such that Q is indefinitely close to P. What we said in the definition, indefinitely close to P. Okay. Now, if we talk about the line PQ, then what is its slope? Its slope is going to be y double prime minus y prime divided by x double prime minus x prime. And this can also be written as y minus y prime by x minus x prime. That is, we are using the 2.4 to write the equation of PQ. Okay. And we also know that both P and Q satisfy the equation of the circle. So x prime square plus y prime square is equal to a square, and x double prime square plus y double prime square is also equal to a square. Now what you do, you subtract these two equations. When subtracting, you will be getting something like this, where a square and a square will get cancelled out, and we will get something like this. Now rearranging the term, we can see that y double prime minus y prime divided by x double prime minus x prime. This will be equal to minus times of x prime plus x double prime upon y prime plus y double prime. Now what we said was that x double prime approaches x prime and y double prime approaches y prime. So here we can substitute x double prime as x prime and y double prime as y prime. So what it becomes is that the slope of PQ is minus of x prime by y prime, and this is equal to y minus y prime by x minus x prime. Now if we will multiply it and bring it this side, what it will become? X prime square, x prime, and this is y prime minus y prime square. So it becomes something like this, that x prime plus y prime equals to x prime square plus y prime square equals to a square. So if you talk about the equation of this tangent, it is x prime plus y prime equals to a square. Okay. So this was the equation of the tangent to a circle at x prime comma y prime. And the equation of the circle was x prime square plus y prime square equals to a square. Now if we talk about a general circle, then in a similar way we can say that what we did here with center 0, 0, we can just replicate it with center minus g, n. Means the entire derivation is going to be same with some more lengthy calculations. And what we will be getting is this x prime plus y prime, which was same in our earlier equation, plus 2gx plus x prime plus 2fy plus y prime plus c equals to 0. So the equation of the circle was x square plus y square plus 2gx plus 2fy plus c equals to 0. Okay. Now what we are doing is, in place of x square we are writing it as x prime. In place of y square we are writing it as y prime. In place of 2x we are writing it as x plus x prime. In place of 2y we are writing it as y plus y prime. And we are leaving c as it was. So this is the equation of the tangent at x prime comma y prime to the general circle. Now let us see that if we can use some other shifting of axis or something, shifting of shifting of axis, or say shifting of coordinate plane to obtain this equation by using this previous result. Let us give it a try. We know that for a circle with radius a centered at 0, comma 0, if this point is x prime comma y prime, then we know the equation of the tangent. Now let us say that our circle is somewhat here, centered at minus g comma minus a, and it has the same radius a, and this is our point x prime comma y prime, and we need to find the equation of the tangent at x prime comma y prime to this circle. How we will be doing it? Now suppose that if we just move our coordinate axis to this point, then the same it becomes the same thing as this. The dark circle has a radius a and it is centered at 0, comma 0. And for this change of axis, what we need to do? We want is that we need to make minus g to 0. That is, we need to add g to the x coordinates, and we need to add f to the y coordinates. Or we can say that this x prime comma y prime becomes x prime plus g comma y prime plus g with reference to the new coordinate axis. Okay, what I am trying to say is x prime comma y prime was with respect to the older coordinate axis. What it becomes with respect to the new coordinate axis, it becomes x prime plus g comma y prime plus f. Why? Why so? Because minus g comma minus f becomes 0 comma 0. So what our problem changes is, now we need to find the equation of the circle, equation of tangent to the circle, x square plus y square equal to a square. Okay, with at the point x prime plus g comma y prime plus f. Okay, so was our equation? This was our earlier equation. Now what we need to do is, we just need to replace x with x prime plus g. Now you can see that these two equations are the same. So this was it. And we can also do it in the previous way, how we did it for x square plus y square equals to a square. That first find the right equation in the two slope form, and then use the equation of the use the fact that both these points x prime y prime x double prime y double prime satisfy the equation of the circle. Subtract those two equations, and then use just get the slope in the form of x prime and y prime, and then proceed. We can do that also, but instead of that we can do this too. Both things are just same, there is no difference. Here we need to know that why we are doing it as x plus g and y plus f. This may be clear that why we are putting x prime plus g and y prime plus f. But we should also know that why we are using x plus g. We are using because this x was with respect to this. But what we need to find is the x with respect to this one. For what I'm trying to say, that if you take some point x comma y, then for the x comma y in this coordinate plane, you need to find the equation of the straight line. The straight line, for suppose this is the tangent, and this point x comma y lies in this plane. So when it gets transferred here, it becomes x plus g comma y plus f. That's why we are using x plus g and y plus f. Now this whatever we covered for the tangent, this was a very general case, that it was we did nothing specific for the circle. Now we will be doing it specifically for the circle, because a circle has a very important property. It has a very good condition of tangency, which other curves like parabola, ellipse, hyperbola, they don't have. So let us see what it is in a stepwise manner. First, let us say that, so if I make a statement that a tangent is a line which intersects the curve at only one point, then is that a statement true or not? In the general case, our intuition will say that this statement is true, but it is not always. For example, consider this curve. If we make a line, is this a tangent to this curve or not? It is a tangent. See, at this point, it is a tangent. But this is not intersecting the curve at only one point. We can easily see that it is intersecting the curve here also and here also. So if we say that a tangent is a line that intersects the curve at only one point, then it is not always true. But for a circle, it is not possible that a straight line intersects this curve, is tangent to this curve, and it again intersects. We can see this by drawing figures, or we can see this geometrically. So in a similar way, if we say that there is a straight line which has a fixed slope m, and it is intersecting the circle at some point. For example, let us say that this is a straight line which has a fixed slope m, and we need to vary the constant c, and we need to vary it in such a way that this straight line is a tangent to the circle. Now, if we vary c, then what we can see that the straight line will intersect, this straight line will not intersect the circle at any point. This straight line will intersect the circle at only one point. So we can see that the second straight line intersects the circle at only one point. And after that, we see that all the straight lines intersect the circle at 2 points. So we can say that the tangent to a circle will be such that it intersects the circle at only and only one point. For y equals to mx plus c to be a tangent, clearly it must intersect the circle at only one point. I am emphasizing this again and again that this is not true for all the curves in general. But we can see that for a circle, it is true that for a line to be a tangent, it must intersect the circle, or it must intersect this curve at only one point. Now, this is a geometrical condition, and we will exploit this geometrical condition to get a result. So let us do it. We can see that uh, when we solve y equals to mx plus c and x square plus y square equals to a, then we will get a quadratic. How? Just replace y with mx plus c in the below equation. So we will be getting this mx plus c whole square plus x square equals to a square. On simplifying it, we get this. Now this is a quadratic in x, and what we are saying that this the straight line intersects the curve at only one point. And if it is so, then the values of x should be only 1, and the values of x will be 1, only 1 if and only if and only if this equation is a perfect square. And for that, what we need is that the discriminant of this equation should be 0. What will be the discriminant? It will be 4m square c square minus 4 times of c square minus a square into m square plus 1. Upon simplifying it, we get this. And upon further simplifying it, we see that the m square c square term gets cancelled out. And what it becomes is that c is equals to plus minus under root a square into m square plus 1. That is, if we know this m, then there are only two possible values of the tangent, and because the c has only two values, plus or minus a times under root m square plus 1. So if we are given a circle, and we are said we know this equation of a circle, and we are said that draw a tangent whose slope is 1, then what will be it? It will be something. Let us say that the equation of the circle is x square plus y square equals to 4. Then what will be it? It will be under root 1 plus 1. That these two lines will only the only tangents with the slope m equals to 1 for this circle. Now, can we relate this condition with that x prime plus y prime equals to 1 that we studied before? Let us see. What we know that at a point x prime comma y prime, the equation of tangent to the standard circle is x prime plus y prime equals to a square. Now, writing it in this slope form, we can say that minus x prime comma y prime will be the slope, and a square comma y prime will be the tangent, will be the intercept. So if we know the m equals to minus x prime comma y prime, we also know that x prime comma y prime satisfies the equation of the circle. Now, if using this, we can just substitute x prime as minus my prime, and after substituting, if we solve for y prime, we get it as plus or minus a divided by under root m square plus 1. And we can just then after that we can convert this equation by putting minus x prime comma y prime as m, and a square comma y prime, we can put y prime as this a divided by under root m square plus 1. and we will be getting this. So what I am trying to say is, using this equation, we just got this equation. So now I want to emphasize that why this equation is important, and why it is important to say that y equals to mx plus minus and a under root m square plus 1. First of all, this is going to be one of the most used equation of the tangent for the circle. First of all, so we need to remember it. And second, the thing is that if you know the slope m, then you know the entire equation of the tangent. So this equation is important in that way. If we know the point x prime from y prime, then we from this equation we know the equation of the tangent. So what is given to us, for suppose we are given x prime comma y prime and we are set to find the tangent, then we will be using this equation. If we are given m and we need to find the equation of the tangent, then we will be using this equation. Both the equations are important in themselves, but we need to remember both these equations so that we can do things in a more quicker way. So this was one condition of tangency. That this was one condition of tangency. That the point, the line, there is only a single point of intersection of the tangent and the circle. Now let us see the more general case. For example, this is the center of the circle, and this is the line. Now if P is greater than R, then the case is somewhat like this. And if P is less than R, then the case is somewhat like this. Now if P is equals to R, then the case is somewhat like this. Here just I have converted that single point condition into this. Now suppose that you are having only a single point. Suppose this perpendicular distance is equal to R. Then any other point cannot have that distance equals to R, because it is any other point will have the distance more than that, because the perpendicular distance is the shortest distance from a point to a line. So both the conditions, that the perpendicular distance from the center of a circle to a line is equal to R, and the condition that the circle and the line intersects at only one point, both are same geometrically. And this we have a more independent and more good geometrical condition which we can use, that if a line is tangent to a circle, then the distance of that line from the center of the circle will be equal to R. If a line L touches the circle, S equals to 0. If P is the length of the perpendicular from the center to that line and radius of the circle R, then both are equal, that is P equals to R. So let us solve a problem to get the things more clear. Find the condition that the straight line 3x plus 4y equals to k may touch the circle x square plus y square equal to x. We can write that equation of the circle in this way. Okay. So the center of the circle is 5, 0 and its radius is 5. Now what we are said is that find the condition that this straight line may touch the circle. If this straight line is touching the circle, then the distance of this straight line from the center of the circle must be equal to 5. And if its distance is equal to 5, then what we can say? Then we can say that 3 into 5 plus 4 into 0 minus k upon 3 square plus 4 square will be equal to 5. That is mod of 15 minus k is equals to 25. That is k equals to if you take the positive case, then k equals to minus 10. If you take the negative case, then k is equals to 50. So in solving this problem, what we used? We used that if a line is tangent to a circle, then the distance of the line from the center of the circle will be equal to the radius. This is the concept that we used. Now, let us move on to the next question, where we are set to find the condition that the straight line ax plus by plus c equals to 0 may touch the circle x minus h whole square plus y minus k whole square equals to r square. That is, we are given h comma k, and this is our circle with a radius r, and we are said that this line ax plus by plus c is tangent to this circle. This line is tangent to this circle, and we need to find the condition of tangency. or we can say that we need to find the relation between A, B and C. So let us see. If AB means if this line is tangent to the circle, then what we know that its distance from H comma K should be equal to R. That is AH plus BK plus C. This is the condition of tangency. That is AH plus BK plus C whole square equals to R square into A square. So this is a very important property of the circle, and we need to be careful about it. Now coming on to the previous problem again, let us see other methods to solve that problem. We are given 3x plus 4y equals to k, and we are saying that it is tangent to x square plus y square equal to 10x. So if we say that put y in terms of x, this is 3x minus k by 4. Now you will get a quadratic in x, and if you make the quadratic in x, if you make the determinant of that quadratic in x, you will get an equation in k. And you will see that when you solve that equation, you will get the same values of k that you get from here. That is, you will get the values of k as k equals to minus 10 and 40. So these are two methods for solving this type of questions, because we know what we know for a line to be a tangent to the circle, that the point of intersection of that circle and that line will be single, and the distance of the center of the circle and the line will be equal to the radius. These are the two things that we know, and if we exploit these two things, then we can get the equation of the circle. And these two will give the same algebraic and geometrical result every time. So it is not that you will get some other equation using the first condition and some other equation using the second condition. These two conditions are the same conditions only. Okay, it is not that these two things are different. This is the thing that I wanted to stress. So let us do a quick recap of what all things we studied today. So first we did this question, which was okay, and then we studied about the position of point, power of point, and then we saw the tangent secant theorem revisited. Then we knew when we started the tangent line of a circle. This was the general definition of a tangent, and to be truthful, we are not going to use it, at least in circles. We are not going to use this definition, at least in circles. What we are going to use is that if a line is tangent to a circle, then its perpendicular distance from the center of the circle is equals to r. And second thing, its point of intersection with the circle is only 1. Now, for a general circle, this is the equation of the tangent. And for this equation of the tangent, what we need to do is we need to replace x square with x1, 2x with x plus x1, 2y with y plus y1, and y square with y. Second, we knew if a line y equals to mx plus c with a definite m is perpendicular to this line, then what are the conditions on c? The c is something like a times under root m square plus 1. That is, c square equals to a square into m square plus 1. Now, if the perpendicular distance, if a line is tangent to a circle, then its perpendicular distance from the center of the circle is equals to r. So these were the things that we covered. To sum it up, so this is a circle with a center 0, 0, radius a, x1, y1 is a point on it. The tangent will be x1 plus y1 equals to a square. Second thing, this is a general circle with center minus g, minus f, x1, y1 is a point on it. Then the equation will be x1 plus y1 plus gx plus x1 plus y plus f, y plus y1 plus c equals to 0. Now again, if this is a circle, this is a line, y equal to mx plus something c. Then if we need to find the c such that this line is a tangent to this circle, then c square equals to a square into m square plus. And the last thing, that if this is a line L and this is a circle C with a center C, then the distance of line L and C should be equal to. These are four key concepts that we learned in this class, and we need to remember them. And they are very basic and preliminary concepts, and they are fundamental and foundational concepts. So we need to have a have them cleared. We need to have a very clear picture in my mind about these concepts. So thanks, and today we are just winding our lecture.